Our goal in this video is to find the probability of one event and a second event occurring. If the events are independent, meaning the first event does not affect the probability of the second event, we will multiply the probability of each event together to get the probability of both events occurring. So let's take a look at this spinner. If the pointer is spun twice, find the probability that it will land on red and then yellow. We're going to find the probability that it lands on red, and we're going to multiply that by the probability that it lands on yellow. And that will be the probability of both of those events occurring. The probability of red is 2 out of 6. The probability of yellow is 1 out of 6. I'm going to multiply those together. 2 times 1 is 2. 6 times 6 is 36. And then I reduce that to lowest terms. And we get 1 out of 18. If you're rusty on your computations with fractions, you're welcome to plug it into Desmos Scientific Calculator, and if you press this little button right here, it changes it to a reduced fraction. Number 2, if the pointer is spun twice, so again twice, find the probability that it will land on a color other than yellow for each spin. So we want the probability that it does not land on yellow on the first spin, and then the probability that it does not land on yellow again for the second spin. The probability of not getting yellow is, well, there's 1 yellow, the other 5 outcomes are not yellow, so 5 out of 6. When I spin it the second time, the probability of not getting yellow will still be 5 out of 6 because my second spin is not affected by my first spin. That's what it means to be independent events. And now I multiply top times top, 25, bottom times bottom, 36. And 25 over 36 cannot be reduced. And part C, if the pointer is spun 3 times, find the probability that it will land on red every time. So we're going to do the probability of red times the probability of red times the probability of red. So we multiply the probability of those 3 events. The probability of red on the first spin is 2 out of 6. The probability of red on the next spin is also 2 out of 6. And the probability of red on the last spin is 2 out of 6 again. Now multiplying the tops, 2 times 2 is 4, times 2 is 8. And 6 times 6 is 36, times 6 is 216. And 8 over 216 reduces to 1 over 27. Now we're going to talk about probability with dependent events, where the second event depends on what happens in the first event. Here's an example to illustrate the difference between independent events and dependent events. Imagine I want to find the probability of drawing 2 blue marbles in a row. There are 2 different types of problems. There's one type where we draw a blue marble, we put it back in, and then we draw another marble and hope it's blue as well. The second type is without replacement. I draw a marble, I don't put the first marble back, and then I draw another. And the first type with replacement are going to be independent events. So when I find the probability of drawing 2 blue marbles in a row, I do, in this case, there's 2 blue marbles out of 5 in all. And then I assume I get a blue marble, but then I put it back. And now I reach in again, and the probability of getting blue again is also 2 out of 5. So my second draw was independent of the first because I put the marble back and I still had the same sample space, meaning the same possible outcomes. And I would get 4 out of 25. Now, without replacing the second marble, these become dependent events. If I reach in and draw a marble, hoping for a blue, the probability of drawing a blue is going to be 2/5 the first time I reach in and draw a marble. Now, we assume that I did take out a blue marble. So one of these blue marbles is now removed. I've taken it out of the bag and it's in my pocket. Now I'm going to reach in again. What's the probability of drawing another blue marble? Well, now there's only one blue marble left, and there are only 4 total marbles left. So my number of blues went down by 1, and the total number of marbles went down by 1. My sample space changed. So my second event depended on what happened in my first event. And multiplying these fractions, we get 2 out of 20, which is 1/10. So the probability is different. So to summarize that, 2 events are dependent events if the occurrence of one of them has an effect on the probability of the other. Here's another example. An ice chest contains 7 cans of apple juice, 6 cans of grape juice, 8 cans of orange juice, and 4 cans of mango juice. If you randomly select 3 cans in succession, find the probability of selecting 3 cans of grape juice. So I'm going to think about the probability of selecting grape juice on each draw, but this example is without replacement. Meaning after I select a can, I don't replace it back into the ice chest. So the first time I reach into this ice chest, the probability of selecting a can of grape juice would be, well, there are 6 cans of grape juice out of, if we add up the total number of cans of juice, 25 in all. So 6 out of 25 is the probability of selecting a can of grape juice. Now the second time I reach in, we assume that I did get grape juice the first time I drew a can out. So one of the cans of grape juices has been removed from the ice chest. Somebody's off on the side of the room drinking it already. So now I'm down to only 5 grape juices left. And also my total number of cans went down by 1. So now there are only 24 total left when I reach in to draw a can the second time. Now again, I assume that I did get grape juice again. So how many grape juices are left now? There would be 4 left and 23 total cans. And I plugged that into my Desmos scientific calculator and changed it back to a fraction using this little button. And it gave me a reduced fraction. 1 out of 115 would be my answer. Part B. If you randomly select 3 cans in succession, find the probability of selecting a can of grape juice, then a can of mango juice, then a can of apple juice. Now, we're assuming that we put all the cans back in and we're starting with all 25 cans again. So the first event is selecting a can of grape juice. There are 6 cans of grape juice out of 25 in all. Now we assume that we got that grape juice that we were looking for. And now we want the probability of selecting a can of mango juice. A grape juice was removed, so all the mango juices are still in there. There's 4 cans of mango juice in there. But the total number of juices did go down by 1 because a grape juice was removed, so there's 24 total. And now we want the probability that we select a can of apple juice, given that a grape juice and a mango juice have been removed. So I have all my apple juices still. There are 7 of them, but my total number went down to 23. This gives us 7 out of 575. And the last example, if you randomly select 3 cans in succession, find the probability of selecting no cans of grape juice. Well, so again, we're back to all 25 cans. There are 6 cans of grape juice and 25 in all. That means 25 minus 6 would be 19 cans that are not grape juice. So if I want to reach in and select something that's not grape juice, there are 19 cans in there that are not grape juice out of 25 in all. Now we assume that we took out one of the cans that's not grape juice. We don't know which it was, apple, orange, or mango, but one of those has been removed. So now the not grape juices are down to 18 and 24 total cans, because the total also went down by 1. And then after we've drawn 2, we assume they're both not grape juice, and we're down to 17 not grape juices and 23 in all. Here's one last example. Consider a political discussion group consisting of 5 Democrats, 5 Republicans, and 6 independents. Suppose that 2 group members are randomly selected in succession to attend a political convention. Find the probability of selecting a Republican and then an independent. So once I've selected the first person, we can't select that person again. So it's kind of like they're removed from the group, just like with the icebox problem. First, the probability of selecting a Republican would be 5 out of 16 people in all when I add the 5 plus 5 plus 6. And then I multiply that by the probability of now selecting an independent, assuming that I already selected a Republican. So for the independents, all 6 of them would still be in the group, but the total number of people went down by 1 because I removed a Republican. So now I'm only down to 15 people in all. And I multiply these together, and that gives us 1/8.